Hi, welcome to Lesson 32, Session 3. Today we're going to be continuing the work that we've been doing with coordinate planes, which I've said, I think, every day this week. We are going to be today specifically representing relationships between quantities. So we're going to be looking at our x-axis and our y-axis and talking about how those two axes relate, or axes relate to each other, and how they depend on each other. We're going to be using real world mathematical problems and putting them into these coordinate planes and getting real data from it. It's really cool. This is probably one of my favorite units to teach. I know I've said that before, but like for reals, this one really is one of my favorites to teach. We're going to be in our Ready Classroom Math Workbook. We'll be on pages 669 through pages 674. So go ahead and turn in your Ready Classroom Math Workbook to page 669. So on page 669, we see the following problem. Jenny had $20 saved in the bank. She earns $10 an hour washing cars and saves all of her money. Wow, way to go, Jenny. Graph the points on the coordinate, graph the points in the coordinate plane to show the relationship between the number of hours Jenny works and the total amount of money she has saved. Include the following in your graph. Titles for the x and y axes to show which quantity each axis represents. We're going to do points for 0, 1, 2, 3, 4, and 5 hours of work. So first of all, we need to look at this problem. So what are we talking about? We're talking about money that's saved in the bank and Jenny who's doing some working. We want to find out, we want to go ahead and we're going to graph the points in the coordinate plane to show the relationship between the number of hours Jenny works and the total amount of money she saved. And then we're going to include all of this information in our graph. The important information is we know that Jenny, she starts and she already has $20 before she even starts because she has that money saved in the bank. We know that she earns $10 an hour, and we also know that one of our axes is going to be labeled the number of hours Jenny works and the total amount of money she has saved. So if we're looking at which of these do you think is going to go up to like 100? The hours she works or the money that she saves? That's right. It's the money that she saves because the hours are only going to go up by like 1 hour at a time, but the money is going to grow pretty quickly the more hours that she works. So we're going to label this axis over here. We're going to label this the total amount of money saved. Total money saved. And then we're going to label this axis over here the number of hours Jenny works. Now, we've labeled our axes. Now we want to go, okay, it says they want points for an X value, the hours of what if she works no hours? What if she works 1 hour, 2 hours, 3 hours, 4 hours, and 5 hours? How much money will she have in the bank? So first of all, we know if she works no hours, does she have any money? She does. That was a trick question. I was testing you. She does have some money because in the problem it says Jenny already has $20 saved in the bank. So even if Jenny does absolutely nothing for the rest of her life, she has that $20 saved in the bank. So if she works 0 hours, she has $20 saved in the bank. So we're going to save for 0 hours, which is 0, our x-axis is how many hours she worked. So for 0 hours, she has $20. Now, if she works for 1 hour, how much money does she make working for 1 hour? That's right, she makes $10 an hour. So if she works for 1 hour and she makes $10 an hour, do I put a point here at the 10? No, I don't, because we have to add that $10 to the $20 she already had. So if she already had $20, in 1 hour, she's going to make $10 more. So that's going to go up to her having $30. In 2 hours, she's going to make $10 more than that. So she'll have $40. In 3 hours, she'll make $10 more than previously. That would give her $50. For 4 hours, she would have $60. And for 5 hours, she would have $70. Because as you can see, every time she works 1 more hour, she makes $10 more because she earns $10 an hour. And remember, we started at $20 because she already had $20 in the bank before she started. So if she worked in one day 5 hours, after 5 hours, she would have a total of $70 in the bank. Not a bad gig. All right, we're going to go ahead and talk a little bit more about this on the next page. So go ahead and turn your Ready Classroom Math Workbook to page 670. So on page 670, we have the same word problem that we did on the last page, but they went ahead and they said, you know what, let's model it. Let's show this in a different way. Instead of showing it in a coordinate plane, we're going to go ahead and show it in a table. Isn't that cool? It's the same information that we graphed on the last page in the coordinate plane, but instead of doing a coordinate plane, we did it in a table. So this table shows the number of hours Jenny works and the total money she has saved. So if she works 0 hours, she just has the $20 that she always had in the bank. If she works 1 hour, she earns an additional $10 from the $20 she started with. If she works 2 hours, she has $40, 3 hours, 50, 4 hours, 60, and 5 hours, 70. So we can go ahead and finish. We also already did this on the last page. So I'm going to go ahead and just graph this on here as well. And it says, using the data from the table to form ordered pairs, to graph the coordinate plane at the right shows points plotted for the first 2 points. So the ordered pair of this point here is 1, 30. For this point here is 1, 30 because she works 1 hour and has $30. The ordered pair for this point here would be 0, 20 because she worked 0 hours, but she still had $20 in the bank. So now we're going to talk a little bit more about what these other points mean and what their ordered pairs would be. So let's go ahead and go over to the Connect It page. All right, so looking at the coordinate plane and picture, what does the x-axis represent? It represents the hours worked. What does the y-axis represent? It represents the total money saved. By Jenny. Now we're going to go ahead and figure out what all of those ordered pairs are going to be. So if our x-axis is 0, what is our y? If our x-coordinate is 0, what is our y? That's right, it's 20. If our x-coordinate is 1, what is our y? 30. If our x-coordinate is 2, what is our y? 40. I bet you can see the pattern now. If our x-coordinate is 3, we have $50. If our x-coordinate is 4, we have $60. And if our x-coordinate is 5, we have $70. So as you can see, these are all of the ordered pairs for the points that we plotted on our in our coordinate plane. So then I already did it. I jumped the gun. Sorry about that, guys. But we went ahead and plotted those original ordered pairs on Picture It. So how much money will Jenny have saved if she works for 5 hours? If she works for 5 hours, she'll have $70. Or if she works for 5 hours, she'll have $70. Or if she works for 5 hours, she'll have $70. There are 3 different ways to find out the answer to that she will have $70. So which point on the graph shows us that she's going to have $70? Well, I already showed you. It is 570. So how many hours does Jenny need to work to have saved a total of $40? So instead of looking at our hours, we're going to look at our money first and then find out how many hours it would take. So if she wants to have $40, how many hours would that take her? That's right. It would take her 2 hours to have a total of $40. Which point on the graph shows this? Well, that would be 2 because the 2 hours, comma 40 because of the $40. So how can you use the coordinate plane to represent relationships between two real-world quantities? One axis will show one set of values in the relationship, and the other axis will show, and you will use the other axis to show, to represent the other set of values. So whatever two values you want to see the relationship between, usually it's something to do with time and money, then one axis will be the amount of time that you work, and the other axis in this case is the amount of money you made if you work that many hours. So that is kind of what, like the amount of money you make really depends on how many hours you work. So the independent variable would be the amount of time that you work, and the dependent variable would be how much money you make depending on how many hours you work. And then finally, for the reflect, I want you to tell me, what strategy do you like best to show, or for graphing points to show relationships between quantities in the coordinate plane? Do you like using the table to then graph it? Do you like having the ordered pairs to graph it? Do you like just interpreting the graph? What is the strategy you like best and why? Go ahead and pause the video and finish writing that out. When you're done, we're going to go to the next page. All right, on the next page, it says this: use what you have learned to solve these problems. So Theron works in an ice cream store, and he uses 2 scoops of ice cream for each ice cream cone he sells. Make a table of values and then graph the points on the coordinate plane to show the relationship between the number of ice cream cones Theron sells and the number of scoops of ice cream he uses. Include the following in both table and graph. We need titles to show which quantity is represented by the X and Y values. And then we need data for 0, 1, 2, 3, and 4 ice cream cones. So we know that we have number of ice cream cones is going to be our X-axis because they just told us. So we're on our X-axis, we're going to write number of ice cream cones. The number of ice cream cones is considered our independent variable. It's not this value over here will depend on this independent value. The number of cones will depend. The number of scoops on an ice cream cone will depend on the number of ice cream cones that we have. So how many scoops? So we know that the number of scoops on the cone. Let's do it here. The number of scoops is going to be our y-axis. So we're going to put number of scoops. I can't spell scoops apparently. Let me fix that. All right, so number of S-C-O-O-P-S. There we go. Now they want us to do values for if we had 0 ice cream cones, 1 ice cream cone, 2 ice cream cones, 3 ice cream cones, and 4 ice cream cones. So if we had 0 ice cream cones, how many scoops of ice cream would we have? You're right, it's 0. We would have 0 number of scoops because we'd have 0 ice cream cones. Now, if we had 1 ice cream cone, how many scoops of ice cream would we need? Oh, I can't remember. Let's go back to the problem and see what it said. Farron works in an ice cream store. He uses 2 scoops of ice cream cone for each ice cream cone he sells. So 2 scoops of ice cream for each ice cream cone he sells. So we know if he sells 1 ice cream cone, how many ice cream scoops would that be? That's right, it would be 2 scoops. Now, what about if he had 2 ice cream cones? Well, each cone would get 2 scoops, so it would be 4 scoops of ice cream. If he had 3 scoops of ice, or if 3 ice cream cones and each ice cream cone had 2 scoops, that would be 6 scoops. And then as you can guess and see the pattern, 4 scoops of ice cream would be 8 scoops. So now we're going to go ahead and remember, each of these are our ordered pairs: 0, 0, 1, 2, 2, 4, 3, 6, 4, 8. Isn't that crazy how you can look at it that way? I think it's pretty cool. Now let's go ahead and plot those points. So if he has 0 ice cream cones, he has 0 scoops of ice cream. If he has 1 ice cream cone, he has 2 scoops. 2 is 4 scoops. 3 is 6 scoops. 4 is 8 scoops. So as you can see, we are moving up. Every time we move over 1 unit, we move up 2 further. Over 1 unit, up 2 more. Over 1 unit, up 2 more. Over 1 unit, up 2 more. So using the table, let me cover, not that you can't already see the answer, but using the table and the graph in problem 7, where would you put a point on the graph to show how many scoops of ice cream would be used for 5 cones? Explain your answer. Well, if we had 5 cones, that would be how many scoops? That's right, it would be 10. So we would go up, we would go to the 5 and up to the 10. And that does match our pattern of over 1, up 2 from the previous point. So we know that it would be at the ordered pair 5, 10, because the 5 means how many cones we have, and the 10 means how many scoops are in those 5 cones that we have. All right, and then finally for number 9, what does the point 2, 4 represent in the graph above? So if we go over 2 and up 4, what does that 2 mean? Yep, the 2 means number of ice cream cones. And then what does the 4 mean? The number of scoops. So we're looking for something that has a 2 and a 4. So immediately we know that this one doesn't make sense because we have, this says 6 scoops of ice cream are used in all. So that doesn't make sense, okay? Then do we have 8 scoops of ice cream? No, because we have 2 cones and 4 scoops. So that one also doesn't make sense. So we have a 2 and a 4, a 2 and a 4. So now let's look and see what it says. 2 scoops of ice cream are used for 4 ice cream cones. Is that true? No, we don't do that. 2 ice cream cones use 4 scoops of ice cream. Yes, that's it. With that, we're going to go ahead and on your own, you're going to be doing pages 673 and 674. If you have any questions, you can always email your teacher. Otherwise, I'll see you next time.